So here's a bit of a quick video I have for you guys. How to boost your air conditioning. I have a 5050 BTU air conditioner here. It's a regular GE model. This is the same one where I disconnected the controls here, set the temperature, and I have it controlled on a relay for the thermostat over there. The thermostat allows me to control the ventilation, the heat, and the air conditioning, you know, and program everything. It's a lot more efficient. I did that in my previous video, a couple videos ago. But now that we're getting into summer again, I noticed the heat gain in here is unbelievable between cooking and the sun hitting the place. Now this place is very well insulated. I have fiberglass insulation behind here, R13 in the whole roof, plus radiant insulation. I have the radiant barrier reflectix, so it reflects the heat out and keeps the heat in. Plus the fiberglass. I know ideally I should have thicker fiberglass for the ceiling, but it's only 2x4s, so what I have right now, as you can see, is already bulging out, and I don't want to compress it, so that's what you got. Anyway, the insulation here is very good, but the air conditioning was an issue. I can't put central air in here, you know, regular central air, nor would it be needed because it would be absolutely overkill. I can't afford a mini split system, which is one of those that the compressor goes outside. It's kind of like central air, but it's ductless. The unit mounts right on the wall. And nor do I have the window space for a larger air conditioner. I only have one window over there that's available. It's barely enough air circulation with the exhaust fans on, so I just have that one small air conditioner, and this one is the one that fits the window. I'm not cutting a hole in the wall and putting a through-the-wall air conditioner because I don't want to be doing that. I don't want to decrease the structure as it is, you know, because I have a lot of weight on the walls. So anyway, this place is very well built. Here's what I put together. I've noticed with window air conditioners, the one thing with window air conditioners is you cannot get it down to a temperature below a certain point without the unit freezing up. Such as if you try to cool a room below 65 and it's a little bit more humid than it should be, the room will not cool below 65 because the coils themselves freeze up. Why is this? There's not enough airflow. Air conditioning system, central air, you want a 15 to 20 degree temperature drop. Now, with that being said, the coil has to get cold enough to remove the humidity. It needs to be cold enough to condense water on it and drip it outside. But window air conditioners, have you ever wondered how frigid the air actually is? The air going into this unit was around 73 degrees. The air coming out was a rock bottom 34 degrees. But there was barely any air circulation, any airflow. It was about 130 CFM coming out of the unit. That's what it's rated for, that's what you got. You'll get a little dust on the filter, that decreases quickly. You keep the filter clean, a lot more air comes out, but it's still not enough. It'll cool a well-insulated small bedroom, but it won't cool this room where you have the heat gain of the sun, maybe about 4 or 5 people in here, plus all the equipment running, and you decide to turn the stove on. There's not enough air circulation. The cold air just sinks right to the floor and it dissipates, and you get nothing. So, what I got and what I put together, I bought a 6-inch duct fan, the same one that's running that. It's 210 CFM, I believe. I also got a wall stack box, and I got an elbow fitting that fits this. I made a deflector and put a deflector on the inside too, because this is the continuation of the vent to deflect the air into this. So between the 110 CFM fan and this 210 CFM fan, I'm pulling a consistent, I want to say with some losses, about 200 CFM total. That, and I rose the vent away from this. Air conditioners also, window air conditioners. You got your cold here, your warm air going in here, your return, and your supply. Well, your cold supply is coming out. There's still cold air going right back in here. It's close. And this is where your ice starts forming. I got it out of there. I siliconed everything. Everything's cleaned up. And now Now I can cool this whole entire room down to 65 degrees when it's 90 degrees out. It cycles on and off every 5 to 10 minutes. It works perfectly. The airflow coming out of that vent, I have a speed control on there. Speed control is in here. I locked it off. This way no one can mess with it. I have the speed control lowered a little bit for this fan, but you have a nice, strong breeze coming out of each side. That side hits that side of the room, and this side gets this side. Temperature gauge right now, with the increased airflow we have, you gotta remember not to hit the coil exactly, otherwise it'll be off. I want to say we have about 72 degree air going in, and the air coming out is around 52 degrees. 49. Around 49 to 50 degrees. So we got our 20 degree temperature drop here. Our 20 degree temperature drop with a lot more circulation, a lot more airflow, and it's still a 5050 BTU air conditioner. But it has been increased without changing anything because the coil itself gets so cold, it is the built-in airflow that limits the amount that it can actually cool. Same as, you know, you have your speed adjustment on your blower fan for your HVAC. If you lowered that and you have the air conditioning on, either A, your coil is going to freeze up, or B, your house is not going to cool in time. There won't be enough circulation, not enough cold air replacing and taking away the warm air. The warm air has to be transferred to the outside, so once you get the heat gain from sun or body heat or cooking, if you don't get that airflow, you're not going to get that heat out of there. That's what I did here. I increased the airflow. And now I want to say we estimate I probably boosted this thing to about 6,000, 7,000 BTU. Small coil, a little bit strong rush of air. You don't want to increase the duct fan too much to where it's pulling too much air because you'll never remove the humidity. You need that 20 degree drop. You need that coil to still be cold to remove the humidity. I have not had any problems with the humidity now. It's been very humid out, and it's nice, cool, 45% relative humidity in here. So, but there you go. It's pretty much as simple as the fact as modifying your air conditioner a little bit. And I insulated this to not only keep the condensation down, but the noise. This is within the room, and you don't have to insulate ducts that are within temperature or climate controlled areas, but I preferred to because of the amount of cold air passing through here. I started getting a little bit of condensation. It limits it down. Now I don't really get anything at all. Plus, it makes it very quiet. As I stand back and start walking back, you can start to barely hear it. You start hearing more of that fan instead now. But there you go. Let me know what you think. If you have any questions about it, I know people are going to have questions about this because it's not something that people normally do, but it's a great way. If you're like me and you have an air conditioner like this and you're stuck with something like that and you don't mind the look of this, it's a great way to boost your cooling capacity. It really is. Either way you look at it. You know, even if you have the same controls on there, you know, regular controls, just turn your duct fan on and put a speed control on there and just leave it on with the fan. When the air conditioning is on, leave the duct fan on. You get a lot more air circulation, and keep in mind, the more you separate the vents, if you have that lower and that higher, cold air sinks, so keep your supply air higher up. And the more you have your supply air facing upward, circulating around the room, the more and evenly it'll cool the room. So, there you go. Let me know what you think.